I'm going to discuss Bresenham line drawing algorithm. This is our lesson number 2. Before we begin, let's read this paragraph. The screen of a computer is a rectangular grid. Okay, the screen of a computer is something like this. A cell in the grid is called a pixel. One particular cell in the grid we call it a pixel, and if you look at this you can see there are 20 rows and 20 columns. Okay, we call this as the resolution of the screen, but practically if you look at a laptop screen, this is an example, there may be this much of rows and this much of columns. If your vision is sharp, okay, you can look at your laptop screen very closely. You will see vertical lines as well as horizontal lines. Then one particular cell, okay, then you can see a grid. One particular cell of that grid, we call it a pixel. Now in your laptop screen, pixel is a very tiny cell, okay, and now here this is the resolution. This is the resolution of your laptop screen. Now let's move to Bresenham line drawing algorithm. This algorithm is used to draw line segments on the computer screen. Okay, so now here Bresenham line drawing algorithm in step form for absolute value of m is less than 1. Okay, so let's see. Now let's try to understand that. So now on a particular screen we want to draw a line segment. There we find the left endpoint. Okay, now if we want to draw this kind of a line segment, what we do is for the algorithm we provide only coordinates of 2 endpoints. Then algorithm should be able to connect these 2 endpoints using appropriate pixels. Okay, so now we have to select x1 y1 as the left endpoint. Now left endpoint, how can you select this? The endpoint which has the lower x coordinate, that is the left endpoint. So this one x1 comma y1, then the right endpoint is x2 comma y2. Okay, now m is the gradient. M is the gradient. Gradient means how can you compute the gradient? Y1 minus y2, we divide it by x1 minus x2. Okay, this is the gradient of the line segment, and these steps we these steps are for a line segment where absolute value of gradient is less than 1. Okay, but once you have learned the algorithm for this particular situation, you should be able to generalize it. That means using a programming language, you should be able to implement the algorithm for any m. Okay, so now let's try to discuss um, now in order to discuss these 5 steps, it's better, the easiest way is to use an example. Okay, then let's move to this example. Now we have to demonstrate how to draw a line segment from this to this. Okay, this is the input to our algorithm, and let's draw only part of our screen. Now x1 y1 is the left endpoint. Out of these two endpoints, this has the lowest x coordinate. Therefore, this is the left endpoint. Therefore, this is our x1, this is our y1. Okay, then this is our x2, this is our y2. Now as the first step, you have to set, yes, you have to set k into 0. Then we move to the second step. We have to fill the pixel x0 y0. This pixel you have to fill, it says, that is, you have to fill x1 comma y1. In other words, this means our x1 y1. Okay, 2 comma 3. Now we move, yes, let's look at here. K equals 0. Then here I have given it like this. We invoke set pixel method 2 comma 3. Then it will light up 2 comma 3 pixel. Okay, then after that Third step, you have to compute pk. Pk means now k is 0, p0 value. In order to compute it, we need a value of dx and dy. What is dx? Dx should be computed by x2 minus x1. x2 minus x1, 7 minus 2. 7 minus 2 means 5. dy means y2 minus y1, 5 comma 3 means 2. Okay. Now p naught can be computed 2 into dy, 2 into dy minus dx. Okay, that is our step 3. In this example, you can see this part. Okay, then we move to step 4. We check whether pk is less than 0. Okay, now you can see p naught value is less than 0, no? Therefore, we have to execute this part. Fill pixel, you have to fill xk plus 1, xk plus 1, that means x naught plus 1. Okay, x naught plus 1 comma y naught, y naught. Okay, xk plus 1. Now this is our new x1. Okay, this is our y1, our x1 and y1. We have to fill now to the x naught coordinate, we have to add 1. Therefore 2 plus 1, 2 plus 1, 3. Y coordinate we keep it as it is. Therefore we have to invoke set pixel 3 comma 3, this one. Three comma 3. After that, we have to compute this value pk plus 1. That means p1. K plus 1 means p1. That is p0. This one. Okay. Earlier value of pk plus 2 dy. Plus 2 dy means 2. p1 is 3. The value of p1 is 3. This part. Then after that we move to this step. We assign k 1, k equals 1. Okay, and go to step 4 if k is less than dx. What is the value of dx? It is 5. Value of k is less than 5. Therefore, we move again to step 4. Okay, then we check whether pk means now k value is 1. We check whether k value is 1. No, it is not less than 0. P1 value, it is greater than or equal to 0. Okay, therefore we have to execute this part. Understood? We have to execute this part. Let's look at here. After that we computed P1, then this one, then P1 is greater than or equal to 0, and therefore we have to execute xk plus 1. Xk plus 1 means x1 plus 1. Okay, and yk plus 1, y1 plus 1. You have to fill this, and this is our x2, this is our y2. x1 plus 1 means we add here, it will become 4. Here 3 plus 1, it will become 4. That means we have to invoke set pixel 4 comma 4. Okay, let's look at the example. Yes, 4 comma 4. Four comma 4, and then we have to compute pk plus 1 value. That is, pk plus 1 means now our k value is 1. pk plus 1 means 2. p2 value we can compute to the earlier p1 value. To this one we add 2 into dy. dy means 2 dy minus 2 into dx 5. Okay, then minus 3. This is minus 3. Okay, minus 3. Now we move to next step. Now our k value is 2. Earlier value is 1, now it is 2. Again it is less than 5. Therefore we go to less than 5. Therefore we go to step 4. There we check whether P2 value. Yes, this time it is less than 0. It is minus 3 and it is less than 0. Therefore, this part will be executed. We have to fill x x2 plus 1 y2. This is what we have to fill. X2 we add 1 and y2 we keep it as it is, and now this is our x3, this is our y3. Okay, now let's see this one. Okay, then p2 less than 0, we have to set pixel 5 comma 4. Five comma 4. That means earlier this is our x2 value. We add 1, it will become 5. This is our y2 value. We keep it as it is. It is 4. Therefore, 5 comma 4 we fill this pixel. Okay. After filling, we have to again compute this one. Okay, I will do it here. P k plus 1. K plus 1 means now our k is 2, P3, pk value, earlier pk value, that is minus 3 plus 2 dy to 1. P3 value is 1. Okay, now our step 4 is over. Let's see it. P3 value is 1. Okay, now I will erase this one and yes, I will erase this part. Now we know the P3 value. We move to step 5. Now new k value, it is 2, now it is 3. Okay, and it is less than 5. The condition is okay. Therefore, we move to step 4. We check whether pk, that means p3 value, it is not less than 0, it is greater than or equal to 0. Therefore, we have to execute this part. We have to fill xk, x3 plus 1, y3 plus 1. Okay, now this is our new x4, this is our y4. Okay, now you have to fill this. That means what is our set pixel? X coordinate we have to increment. Earlier our x3 value is 5. So we add the 1, it will be 6. Earlier y3 value is this one. We add the 1, it will become 5. Okay, so let's see. Six comma 5. 6 comma 5, we fill this pixel. Okay, after that we have to compute pk plus 1. K plus 1, that means p4 value, earlier pk value, that is 1, p3 is 1, plus 2 into dy 2 minus 2 into dx minus 5. Okay, p4 value, it is minus 5. Now our step 4 is over. We move to step 5. There k will become 4. K will become 4 and it is less than 5. Therefore, we move to step 4. Okay, then I will write that part here. Okay, then we check whether p4 value is less than 0. Okay, therefore, since it is less than 0, we execute this part, fill sk plus 1. Okay, x4 value is yes, x4 value is 6. Therefore, in set pixel x4 plus 1, therefore it is 7. Y4 we keep it as it is, so it is 5. 7 5. So this one, 7 comma 5. Now let's see. Here p4 less than 0. Now set pixel 7 comma 5. Now after that, here we have to compute pk plus 1 as well. Now our k value is 4. Now k5 value are here. Then the other thing is, this is our x5 and this is our y5. Okay, x5 and y5. P5 to the earlier value P4. P4 value of P4 is minus 5. Okay, minus 5. Then plus 2 dy, 2 dy. Okay, that's all. This will become minus 1. Now step 4 is over. We move to step 5. Before that, let's see whether P5 minus 1. Okay. Then we move to step 5. We increment value of k. Now earlier k value is this one. Now k value is 5. Therefore, it is no longer less than 5. Okay. Okay. So, this condition is false. Therefore, that is the end of execution of these steps. That is the last line. 5 is not this one. Okay, 5 less than 5. This is wrong. Okay. Therefore, that is the end of execution. Okay. Now you can see we have drawn the line segment. As the input, we have provided only the coordinates of the two endpoints. Then using the algorithm, we have drawn the line segment from here to here. Okay, that is the Bresenham line drawing algorithm. And thank you for listening.